Okay, we are live.
Hello students, it's a pleasure to meet you all. My greetings to you. We are present here. We are present here to have a live chat with you. During the course, during this course, you must have come across number of questions to ask me. You must have been keen to ask me. We are here to solve many of your questions and other related queries, and we are also available to you online, offline, anytime. During the start of the course, I had given you my telephone number and other things with which you can communicate with me. So in this course, we are almost nearing the end of this course. Only battery and what is the last one? Huh? Zero liquid discharge. Those two have chapters need to be completed, and it is. I want to tell you that this course has undergone a phenomenal transformation from what I had imagined, and that I would be teaching you, to what I have already taught you and what I am going to teach you also. So in the initial stages, it was Malinka. In the initial stages, I thought I will teach you only a little bit about the electronic structure and start teaching you about the electrochemical techniques. But in the meantime, I realized that there could be people who may not have the basic grounding in chemistry, especially solution chemistry, which is so essential for our electrochemical course. Then it underwent that kind of transformation to introduce basic concepts of uh, electrochemical studies, as well as the basic concepts of solution chemistry. So that has taken a little bit of extra time. And then we have also realized that apart from analytical techniques in pollution monitoring, there are many other things which are much more important for you to understand. So that is how the chapters got added one after another, one after another. Especially finally, we decided that apart from just the electro-analytical techniques which we intended to do, I wanted to continue and teach you about ion selective electrodes, electrochemical sensors, process waste handling, and then electroplating, which is a very important industrial activity. Along with that, we need to discuss about batteries, and then zero fuel cells, zero waste, zero liquid discharge, etc. And all these things have made this course itself a sort of unique something, which to be cherished. Actually, I feel that this is a complete course in electrochemistry. We need to introduce this kind of courses in the university also. So let us now we are almost coming to the end of the course. I want to introduce Rajiv and Harshita. I think most of them uh, you know already. They have been the mainstay of our course. They have been interacting with you all the time, and they may have something to say to you. Afterwards, what we will do is we will go through some of the questions what you have been asking, and if there are any additional things we need to know, please let us know so that we can continue and keep the dialogue going on until we finish the course logically. Is that okay with you? I assume so, because we are unable to have something like a Skype.
No, we do have.
We do have. If somebody wants to say something,
They can.
I would be very happy to have your inputs. But before that, what I wanted you to do is listen to Rajiv and Harshita, what they have to say about the course. Rajiv?
Welcome all the students. I hope this course has fulfilled your requirements of studying electrochemical techniques, which is particularly pertinent to study pollution monitoring itself. As Professor already has indicated, this course has undergone a sort of a very dramatic shift in terms of its content and treatment towards pollution control. Uh, any pollution control with electrochemical techniques is incomplete without understanding the basics of solution electrochemistry, or even basics of atomic structure and properties of solution, etc. So I hope so. It's a little bit. I admit that it might be a little bit confusing
Exhaustive.
and exhaustive in the beginning per
Very
se.
true, very true.
So, but I hope those who have lingered on, you will definitely learn to appreciate that this course would have given you some amount of confidence in looking at certain problems relating to electrochemistry. Whereas we are looking at the kind of forums, the kind of questions which have been put up, and we are trying to diligently answer them as soon as possible. And the another shift which the NPTEL course has suggested this time is putting up the answers for the assignments, which we were not priorly doing it. So I hope that you have been going through the assignment questions and their particular solutions, which will probably benefit you in understanding how to solve the particular problems, or how we look at trying to solve the particular questions. Um, if you have any questions relating to the assignments, you can ask on this forum. For example, you're on the YouTube channel, you can ask me. Okay, we have the first couple of questions already. We will answer them. There is
After
Sundar Ram
Harshita used
Swaminathan
to
has
say
already asked
something.
these questions. We'll answer them
Yeah.
step by step. I'll suggest that you keep on asking putting up the questions up on the NPTEL YouTube channel, so that we'll be able to answer them sequentially. Yes.
We
And
also would like to add here that in case it requires more time, more elaborate this thing, we will shift the same question to the
forums.
forum so that we will address it in with proper perspective,
Yes.
in detail also.
Yeah.
Here, I do not know how much time we have for individual interaction, but I do not know how many of you are participating in this course. I don't remember right now in this chat.
Harshita madam will be able to.
Approximately 150 is a fairly good number. It is an impressive number, isn't it, Harshita? 150 is a fantastic number. First time I am enjoying such a huge class. So I want to thank you and congratulate all of you for being part of this course. In case you need any other courses related to pollution, etc., please do write to us. We will plan for that in future also. So now can we have?
We can have Harshita ma'am over so that they'll
Yeah.
understand her perspective as well.
Good evening, everyone. This is Ashita, and electrochemical technology in pollution monitoring is a very interesting and important as of now. Uh, as a biotechnology student, sir was explaining is in a very good manner, and it is understandable for everyone. The students are asking for a notes. We will give you shortly.
The PPT notes are available to them all the time, I think.
Yeah.
Isn't it? So if that is the case, then you can study the PPT itself, because most of the questions have been derived from the PPT presentation, so that you should go through the PPT presentation carefully. Then you will be able to glean 90% of the answers from the PPT. Only thing is you have to look at it carefully, listen again and again. Now, may we can have the first question or something, some input from you people.
Okay.
Sundar Ram
Okay. So
Swaminathan.
shall we?
Yeah.
We will now proceed towards the question and answer section. Okay. And just give me a minute here.
There is some time delay.
Yeah.
Because I am still talking.
Okay. Okay. Anish Kumar has asked a couple of questions which are already with us. I will read it aloud to you, Professor. Then maybe you can answer those
Sure,
questions
sure.
up. He has also put the same questions on the chat box as well.
Okay.
Okay. So, Anish, yes, we are looking at your questions initially itself. Um, okay. So here is his first question. Can you suggest any electrochemical sensor which is easy to make in home with less cost?
Oh yes, we can do electrochemical sensors with a very less cost. The point is, there are some of my students have already done these electrochemical sensors in my laboratory, and they have done it. It should not be difficult at all. Only thing is you will have to buy the digital components and some of the components, and there is nothing like science in that. They are readily available electronic components you have to assemble. Only thing is the
Output
challenge comes in the form of
sensitivity.
characterization
Yeah, and the sensitivity of the components
and the component.
which
For
you
that,
particularly find.
you need a certain amount of laboratory support,
Right.
which we are ready to help you with that in case you are interested.
So, Anish, I hope that's your answer to your particular question. Maybe if you're interested, maybe we can look at it in slightly more detail because this answer is slightly short for your question. Uh, some of the questions are not exactly technical, but I still think we can answer them.
There is something I see from Anish Kumar about transport phenomena, whether we are interested in that
Yes.
or not.
So what he says is, how do you encourage a chemical engineering student when he is more interested in a chemical reaction engineering course rather than an electrochemical course?
Okay. Regarding this momentum, heat, and mass transfer, Anish, it's a sort of the general parameter in which many chemical engineers are automatically involved. So there is no sensor as such for momentum or something like that. But mass transfer, definitely it is a material transfer, and material will be expected to be having certain chemical characteristics as well as physical characteristics. So if we can monitor any of the parameters that define the mass which you are trying to measure as mass transfer or heat transfer, etc., it should be possible. But definitely, it is not a way of pollution monitoring, basically, because in general, chemical engineers are concerned with chemical material reactions happening in a chemical reactor,
Right.
that will be in confined space within boundaries at finite boundaries. But here in pollution control, what we are talking about is heat and mass transfer in a sort of diffuse box. So the box may have varying coordinates. So answer to your question is in principle yes. Heat, of course, one can monitor up to zero point 0.1 degree accuracy. Mass transfer, as I told you, it depends upon the chemical characteristics of the material. So definitely it can be done.
Anish, per se, I don't see a very big difference in your chemical reaction engineering course and in treatment to electrochemical methods because all of them ultimately relate to the same science. I'm not sure where you're, with which angle you are coming asking these questions. Is it something to do with battery technology or something? If it is,
You need to be
then
more specific
then
about it.
we'll be talking about a lot of battery and fuel cells in the coming lectures. So just hang on till we come there, and maybe you'll probably become more interested in the this particular area of science. Uh, okay, and yes, we'll take up some more questions, but let me just go back to Sundar Ram Swaminathan. He asks the question, what is H2O slash MEOH in ml and Karl Fischer titration mean?
So that is a very simple this thing. You can either dilute the sample containing water with MEOH. So methyl hydroxide, methyl alcohol normally reacts with water, binding the water. So one molecule of water will be equivalent to one molecule of methyl alcohol. So if you look at the chemistry of that, it is basically for binding the addition, for the reaction proceeding to have second molecule reacting with the Carl-Fisher reagent.
Okay, if this is something, Sundaram, if this is something related to the assignment questions, you can probably type it here. We will see whether this question related to one of the assignment questions. Then we can treat it in slightly more detail here.
At this point, I also want to add that methyl alcohol is a solvent. It is a polar liquid, and you can't have water as a diluent when you want to determine water as a component in a crystal or something like that. So, water or methyl alcohol, we have written. Any other question is there, Rajiv?
Uh, I think, if I'm not wrong, let me know, Sundar, if this is the question you're referring to from assignment number 5, question number 4, where the excess of Carl-Fisher reagent was equal to 2.25 ml in H2O and methanol. If this is the question you're referring to, let me know. We'll treat this in more detail. Otherwise, we will continue with our questions. Okay, so thank you. If you have got the question, then you don't need an answer solution for that. So if there are any more questions, let us know.
Typing something?
Yeah, he's typed. He just typed that it is related to the assignment question.
Oh,
He understood what you just explained.
Okay.
Yeah. So if there are some more if there are any more questions, please free to ask, and we will be able to help you out. If there are any other questions which you want answers to, then we'll be happy to help you out. Okay, let us take Anis' another question, sir. He asks, what is the most valuable or satisfied project that you have done which makes you feel proud by yourself as an electrochemist?
Very interesting question, Anish Kumar. We have been doing so many things in electrochemical technology, especially with respect to some of the measurements at nano level. We have done many things, but I have to tell you very frankly, the boundary defining boundary as electrochemistry has become sort of um, more diffuse. I cannot really say, but some of the projects which we have been doing, they all had something to do with electrochemistry. So we do not consider electrochemistry as a separate science. It is part of a general uh, evolvement of a science that includes not only the measurements but also the other products that come out like the sensor, batteries, and the other things. They are all, we have done many of those things. One of the projects what we did was about the respiratory masks which I have developed, for which I got the Best Engineering Material Award, for which absorbs organic compounds, and we use it as a respiratory mask. It also has worked for SARS bacteria as well as corona also it should work.
SARS is a virus.
SARS is a virus.
So
Sorry, thank you. I did not know that it is a bacteria, but SARS is a virus. But corona also, the size of the corona and the nano particle, nano pores that are available in the activated carbon fabric. We have done some electrical measurements, disinfection measurements. Some of the things which are done are really interesting and challenging. We wish to continue that kind of work even now, God willing. Let us be very frank and pursue the thing, because science is something exciting, it is challenging, and it is worth living for. Thank you.
In the same vein, let me just, he asked another question. I think we have some time. What is the biggest blunder that you have done which makes you invest in which makes you invest more in your project? I think, are you asking this from a project point of view or building your own sensor?
Blender or blunder, I do not know.
I think he means blunder. Blunder, I think.
Biggest blunder that you have done which makes you invest more in your project. I do not understand what exactly you mean by that, Anish.
Anyhow, maybe we can
That,
discuss this.
that sentence itself, I do not know exactly what you have in mind. So
Maybe you
it's
can
not very clear.
you can talk to us more in detail on
Hmm?
the email or on the forum, and we'll probably be able to help you out better if we understand you more clearly.
Invest what? Money or
I think
time or energy?
I think mistake which you have done, which causes a sort of a roundabout in your project cycles, person.
Oh, we do a lot of mistakes while doing the experiments and characterization and many of the things, because for the first time we have done a fabric, activated carbon fabric, for which many of the parameters were simply not defined. We had to define the new parameters and monitor those parameters. So it's not a, I don't call it a blunder as such, but there are no guidelines, previously made guidelines or standards available when we made the respiratory masks, etc. So that it made me invest more time in my projects now. So it always is a challenge. Uh, Mistake, I do not know. Somebody else should tell me if I have made a mistake rather than me telling that it is a mistake. Huh? Anish, what do you say? I do not know exactly what you have in mind, basically, given now. But I try to answer some of the things, to the best of my ability.
Coming to that, now I hope that your questions or doubts are being put across in forums, because forums is a place where we can easily monitor your questions and sort of gauge the progress of your learning as well. So I suggest, I mean, I would encourage all of you to use the forum more regularly, and yes, let us know if you need particularly any help. Yeah. In terms of other things, in terms of the books you can refer to, I think the notes are, I mean, whatever the professor
Self-sufficient.
has been teaching you is sufficient, because it includes an amalgamation of many different notes and structures. But if you do want to learn something on your own, then there are a couple of books which you can refer to. One is by Quantitative Methods by Vogel.
That is third edition.
Third edition. Okay.
There are newer editions. I have seen only the fifth edition. That also contains essentially the same material. But if there are newer editions, I have not seen them. And then there is one more book on Khopkar by Khopkar, Professor Khopkar from IIT Mumbai. He has written. I have taken quite a few problems from that, and
You'll be giving away the answers now.
yeah, it's okay. I mean, students should know the answers. You see, well, the way I look at it is, the more problems you solve, no, the more mastery you will get over a topic. So you just can't master a subject just by reading and reading and writing and writing.
Yeah,
It's not the way.
I agree that. So yes, the questions have, as professor has already given you the clue, many of the topics are taken from quantitative inorganic analysis by Vogel, and some of them from Kopker book as well. So if you do feel that you need more information regarding that, you can definitely refer to those particular books. If you have any more questions, do feel free to discuss here. Um, Till then, we can discuss about the subject and its treatment, or the way it should probably evolve. Because per se, I don't see a point of having a subject which is not evolving, because every time you look at it, it's a different way of treating it. So, Professor, probably you can shed some light on how you can, how, where else apart from, let's say, pollution control, these things can be used. Or
Uh, See, The point is the focus of the course is on pollution control, but on day on day-to-day basis, there has to be there is a rather there is a huge requirement of sensors and batteries and fuel cells. You just keep your eyes and ears open, you will see many applications. Most of our rockets and other things, they can be made to work on fuel cells, hydrogen cells, and batteries. Batteries, of course, we need not tell, because the whole world is running nowadays almost on lithium cells, and lithium batteries I have covered quite extensively. And the point is, when we have so many batteries and they do have a short life, what do we do with them down the line? It contains many metals. It contains a lot of lithium, which many times I have seen people throwing away the batteries when there is still certain amount of charge.
Charge left, yes.
And when they connect, there can be accidents and there can be fires, which may go out of control, etc. There are quite a few problems associated with these things. So best thing is those three R's: recycle, reuse, and what is the other one? Uh, there is one more, three R's: reuse, recycle, and anyway,
Reuse in the creator.
I'm unable to remember the third R, but you will be able to see it in the Google. So the
Right.
applications, you can see batteries and remote control drones, cameras, etc. They can be used in geochemistry and locating the ores. They can be used. They should be useful in the field, wars, water divining, and all those things. There are quite a few applications. The more you delve into them, the more and more you will be amazed to see the applications.
Yeah. In terms of all the electrodes which we have just discussed, all of the electrodes particularly work on some sort of electrochemical reactions which occur in them, and being miniaturized nowadays, it becomes very difficult to. You can improve the sensitivity, but the life expectancy of those particular electrodes is becomes at a cost of the sensitivity.
That is
Maybe.
where a lot of research is required to check their stability under different electrolytic conditions. For example, the same electrode which works in a simple laboratory condition may not work in our body or in the brain.
Right.
When you insert the electrode, there could be so many host of other chemicals which may make it difficult to interpret the results in terms of experiments done outside the laboratory, or in vivo and in vitro. They can behave totally differently. So that is where a lot of research is required.
Maybe, Professor, you can discuss a little bit on electroplating itself, electroplating as an industry, and its effects on pollution control.
Yeah, definitely we should be looking and talking about electroplating. Without the discussion on electroplating, no amount of this kind of live session should be fruitful. First of all, I must tell you that electroplating as such has undergone a huge change since last 20 years, and we are aiming at sm- smallest and smaller coatings in terms of thickness. So basically what we are talking about is the hardness of the coating as well as thinness of the coating. So the the nomenclature as electroplating itself has undergone a change, that we call it nowadays as surface engineering.
Right.
In surface engineering, no, Harshita, there are many techniques have evolved, which are something like atomic force microscopy and other
Right.
things, which will pinpoint the pollutant atoms in numbers. And we are talking about the detection limits and determination limits. of the order of about 10 raised to minus 15 grams. And we are talking right now, these new techniques, they will tell you about 10, 20, 100 atoms on a surface, on any surface. So you can imagine the amount of the effort required to check the number of small number of atoms on a surface. So electrochemical properties also keep on changing depending upon the coating.
But what about the technology related to electroplating coating? Do we still use regular dip coating methods, or do
We
we go
do,
for spray? Or
yeah, we do go for dip coating and then electroplating as such, and then we also have um, what is that? Electro,
spray?
no, the printing.
Right.
uh, Electroprinting in on a specific this thing.
Right.
And then we also have the LED, which are connected with
Right.
the printed circuit
Printed
board.
circuit boards. PCB.
Printed circuit board. They all have undergone fantastic changes, but at the same time, the quantity and quality of the chemicals that go into those electroplating chemicals also have undergone a tremendous change.
Right.
And there are not many people who understand the chemistry of the additives used in electroplating.
Right.
So, if you don't understand the chemistry of the additives, how are you going to treat them in the end?
Right. Disposal becomes
Disposal itself becomes a big challenge, and that is where a lot of research is required. And thin film coatings, and many of them can be done. Electro deposition, electro vapor deposition, and so many other new techniques are coming.
In terms of pollution per se,
Hmm.
what are the kind of typical sort of pollutants do you see from industries which are solutions, let's say, where electrochemical technology is used? What are the basic matrices or the solvents you'll probably be checking?
No, we should be really worried about the metal ions in the effluent, disposal of metal ions in the solids, for example, in hazardous waste and solid waste, etc. And we should also be worried about the organic solvents that end up in our waterways.
Yeah.
So we do not know still how to purify water to the nano level if they are contaminated with some of these solvents.
Are we able
And
to determine by electrochemical techniques the solvents per se?
not all. See, electrochemical technology, just like any other technology, is capable of solving specific problems in a special way, which where other techniques fail.
Right.
So it is one of the preferred technology that can be used where it is necessary.
So
It is available.
since most of the solvent is water,
Mhm.
and the ions which come out, this electrochemistry is a very important tool in analyzing pollutants.
Definitely, definitely. We have electrochemicals and ion selective electrodes. They can work perfectly all right in many of the online monitoring systems. Are there any other questions from the comments? I would be happy to hear comments from other participants if there are if they wish to say something. I understand there are about 140 students participating in this.
But not all of them are.
Not all of them are participating. I would be happy to have your comments as well as your views about the course, about the. Sometimes you may feel that you should have learned something different, and if you can indicate, we can modify these courses later.
With respect to some of the forum questions, maybe we can take up a couple of questions there.
Sure. Let us see what are the forum questions.
there are a couple of questions related to assignment number 5.
Mm.
Same question.
Okay. We want lecture notes for further study in electrochemical technology. We really need lecture notes.
I think we will address, it will be done. My Harshita has already, you have already said that it can be done now. So the PPTs will become available to you before the examination, and we will make sure that you will get them. Okay.
Jyoti is saying that she is not able to answer question number 4 from the assignment 5. Can anyone help? Yes, I think these answer to these questions will be declared very soon. Will be put up online.
Along with the reasoning, we will declare the answers so that you will know the correct answers. We have already done some of them in the previous assignment.
Right. Apart from that, we should be. If there are no more questions, then we can stop the live session.
Hmm?
All right.
Almost.
My exam tips are solve all the problems that are solved. Okay, that is number one. There is nothing like learning a subject by solving problems. And up to, for example, up to polyrography, you have lot of problems. After that, there are not many problems, and
It becomes descriptive
it
again.
becomes a little bit descriptive. But you can go through them carefully, because especially with respect to fuel cells and sensors, etc., there are certain things you should understand regarding the chemistry, hydrophilicity, and then hydrophobicity, and all those things.
We will
So
be
try to
here
understand
to.
many of those things. What I suggest is each chapter you read 3-4 times, and then try to understand what is being taught.
Yeah, approximately, you can give them an idea of how much effort they need to put in on every lecture, per se.
No, the point is, if they go through every lecture about 3 to 4 times, every PPT, they will not have to worry much about it. And the question paper format is already known to them, isn't it? It's already put up by NPTEL. And once the format is known, you will know what kind of questions are coming.
Right. So we can wish them all the best.
So I wish you all the best. Thank you very much for being part of this program. If you feel like, we will continue our discussion once again, either in this forum or in Google Forum. Thank you very much.
Thank
Have
you
a
all,
nice
and
evening.
all the best.
All the best to you.